What's up, world? We're back with Tui Time graphics, and we now have lighting, so that's pretty cool. Today we're going to move on to something a little different. It's going to be more kind of game engine based, so it will be we want to do terrain generation. So when in a game or in a world, say you're playing Skyrim, you're walking on the terrain, the ground, and it goes up, there's mountains, and then it goes down, and well, really all that is a bunch of triangles that are a height applied to them, and I'm going to go over that in a second. But first, let's just go back and just, oh boy, so cool. All right, yes, so this should be a pretty quick episode. So let's jump into it. I made a little patina guy today to describe what the hell I'm talking about. Let's open up this terrain generation guy. Okay, I'm gonna close you, open you up. Okay, so basically what we have is if you want to make a terrain, you can do one thing. It could be just a flat terrain. So if you were playing Minecraft and you say generate super flat world, you could just create a flat terrain and use an image. If you've ever done game programming before, you can say sprite, right? And you can just put this guy over it. But what happens? Oh, I need to. Oh shoot! All right, let's just say that was perfect. All right, I'm gonna grab this. I thought that would work. Weird. So we're gonna put that right on the edge, and let's say we use this one image, and oh god, stretch it out over the entire thing. Look at how ugly that looks. And so we're not gonna do that because we lose all the quality. You can get this is a 128 by 128 picture. You can get a 5 bazillion by 5 bazillion picture and go ahead and cover this whole thing and make it look perfect. Be my guest. But there's an easier way to do that. That's to take this image, reuse the same image over and over and over again, and at its correct height, 128 by 128, and let's drag it down here and just reuse it over and over again on the same height. Just create multiple textures. So put one right there, put one right there, you see. So it creates sort of the same illusion of terrain, but over a bigger space. So this is a little grass image I found. You can find any image you want for the ground, but I just wanted to have a little grass because that's the most generic thing I could find. So what we can do is we can write a loop, a double loop that will go through the y-axis first and say forever many of these pictures you want to draw. Oh my god. Forever how many images you want to draw them. So it would go over this entire thing, and it would say, all right, cut it in half. So let's do the math kind of right now. So the way in which we would do this is we would loop over it. First we'd start with the y, right? And we'd go this direction on the y. So we say y1, or 0, I guess. So 0, 1, 2, 3. That's not a 3. We're going to say it looks like enough like a 3. So we're going to say on the 0y, we're going to go across that first. And now for every one of these, we're going to draw these indices. Now, where we draw these indices is kind of interesting. We are going to want to, I took notes just so I don't miss anything. Again, like I always do. I don't want to steer you guys in the wrong direction. Be here for 4 hours looking at bugs. Yeah, so basically this is 0. So this right here is going to be the 0th. And then we're going to take this 0th and we're going to divide it by the so the count of the vertices. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, there's 10 here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and then it's actually going to be, this is the 0th right there. So this will be 0 over the vertices, so which is 10, right? So because 0 over 10 will give us 0. 1 over 10 will give us 1/10, which is, this is 1/10 right here. And then this is 2/10, 3/10, 4/10, right? And then in order to give this grid a size, because I mean we could do that, but it would just be 1 by 1 by 1. We wouldn't want that. We want to give it some sort of a grid size. So this right here, this size right here, like from here to here, would be the same. So we would say multiply that by whatever grid size we want. So if we wanted this whole entire thing to span 1,000, right there, so we wanted the whole thing to span 1,000, we would just do it divided by 10 times 1,000, because this would go 0 over 10 times 1,000. This would be 1 over 10 times 1,000, so it would give us 10 times 1,000, which is 2 more zeros, 100,000. So there would be 100,000. 10 over 100,000 would eliminate one of the zeros and give you 10,000. So this would be about 10,000. You see what I'm saying? So that's kind of how it works. And then it'd be 10 over that, which is like the decimal value. So that's how you do that. And then you do the same thing for the Y. The Z vertex, you could just do it, except for the use the Y, obviously. Okay, and then once we have that, it's going to draw all these vertices, right? And remember, we had to draw the indices. This is going to be basically a primitive. We're going to use primitive class for this, and we have to draw these indices. Now, how do we do that? Well, the easiest way to do it would be to, and the way I'm going to do it is go 0, 1, and then 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. And then do it again here, 0, 1, 0, 1, 0, 1, 0, 1. So it's going to just kind of go alternate, and you can use something called the modulus, which just looks like a percent sign. So we'll use the modulo 2. So it'll go 1 mod 2, which is remaining 1, right? And then, so it would, yeah, it would say remaining 1. So we go 1. 1. And then we go 2 mod 2, which equals, oh man, this is being a little slow. Again, sorry guys. 2 mod 2, that's a 2. This is a 2. Mod equals 0. Okay, so I'm going to put the texture at 0 again. See, so we'll just do it that way. I have the code written over here on the left-hand side. Can't see it. I'll give you a little, oh! If you got that, go ahead and just pause it right there, code it. However, I might do this. So let's go ahead and create a new class called terrain. So new file. We're going to call it terrain, and it's going to be a primitive. So terrain. Look at that. We're going to delete this stuff. Just go import metal kit class terrain primitive, which will be a renderable and texturable, so we don't need to worry about that. All we need to do is nothing. We need to override the function of building vertices. Right? Yes. So there it is. So now we can build the vertices, and since we're going to be populating the indices and the vertices and the indices, we just need to create them real quick. So indices equals this. Oh, that's not it. That, and then vertices equals that. And then I'm going to move this up. It's right there. Okay, so we have our vertices and we have our indices. Let's populate. Oh. Okay, so basically the first thing I'm going to do is I'm just going to create a let variable up on top. Actually, you know what? We can't do this yet. I just realized we never actually implemented our primitive just with normals. See, we have the, let's comment these. We have the vertices, the color, the texture, coordinates, but we don't have any normals. Okay, so we're gonna basically copy that, put that right there, make sure we change the comment, important. Change all these to 3. Okay. You can change them however you want. I'm gonna change them in a really messed up way. And the normal is just gonna be 3, and we'll apply those. It's really easy to add a normal because since Patina. Scroll down. More room. I think this is gonna work, so maybe. Ooh, yeah. Oh, what is he doing? I don't even know. I don't even know. Oh, is he creating a plane? Okay, so let's pretend this is our plane, and then there's the triangles right there. See how we have the, okay, let's draw the y-axis. You know what? I'm going to draw the y-axis, the x-axis, and, well, I'm not going to rotate it. Z-axis is coming at your face. At your face. Okay? So basically, did this for a reason. Oh, it doesn't work. Oh, can I put this over it? Of course I can. Okay. Okay, so we have the x-axis, the y-axis, and the z-axis is going directly through here. With that, take it down a notch, right there. So it's going directly through right there, and so basically this is going out in the z direction, right there. And then what we can do is, since these right here are just little, these right here are vertices, we can give them a height of y, and then we can move them up this high and put the vertice, move the vertice up to right here, and then move all of these vertices up and create mountain ranges using that z, because there's going to be a bunch of them. There's going to be thousands of them or hundreds of them, whatever you want, whatever quality you want, but you'll be able to work this y factor right here, and then yeah, you'll see. We'll get into it. That's how terrain generation is done. It's pretty cool stuff. I'm not gonna save that. That's junk. It's not junk. It's important. All right, and then I just need to add one of these things. So now that we have our, that was a freaking there. It's gonna do vertex.stride. Let's make sure that our vertex.stride is, nope, doesn't. Yeah, knew it. Normal. Float 3. I'm gonna go Command B. And we're gonna build. And it's going to be just dandy, hopefully. Okay, so look at that. Now that we have that going for us, pretty cool stuff, I am going to go to our terrain class, which I'm going to actually put up there. And let's start building. Okay, so like I said, we need a double for loop that goes over the y first and then the x, right? So for y in 0 ... less than, oh shoot, we need a let variable up here. Let grid size, which is going to be a int, equal, let's say we're going to do 100 by we're going to say 100 by 100 for the grid size, and then let vertex count, which is an int, equal 10. So it's going to be a 10 by 10 grid. It'll be a 10 by 10 grid that spans over 100. So 100 in our projection matrix units. So now we can say for I is less than vertex count, and then just do that. And then for x in 0 ... less than vertex count, same thing, because let's go back to our image that I threw away. All right, so we're gonna go over every single vertex first and just apply them in a two-dimensional fashion. Okay, very simple stuff. All right, so let's just call this y. All right, so one thing I want to get into, that the reason I have this hard-coded, so I did this before, and what I ran into was floating precision point values coming amiss. You can't, there's certain ways in which you have to do mathematics in Swift so that it comes out correct. You can't divide and then apply a float, or you got to divide two floats, or there's all these sort of different things you got to play around with. But I played around with it until I got it just right. So I'm going to do that exact same thing over her. Okay, so this will just be the vertex for y, and I'm going to say that that is a float, and that's going to equal, like I said, let's do I. Float I divided by an entire float, right? So we're going to do a float divided by a float. This will be a float of vertex count. Just want to do it. Float vertex count times the grid size. Oh, well, the entire thing by grid size. So, oh, -1, right? Because we need to put it back to 0. That's the one thing I didn't actually tell you in the pit. So the reason I messed up my little generator thing was because instead of doing 0, 1, we're going to go -1. So it's going to be 1. So it's going to be I. That's a J. Whatever. This is an I. Over vertex count 0 -1 times grid size. So this will be times grid size, which we'll say is 100. So this will be -1 times 100. If I is 0, it's going to be right there. Now if it's 1 minus 1, it'll be 0 times 100, which will be bad. Don't want to do that. No, this won't be 0 times 0. It will never be 0 times 0 minus 1. Then it'll be 1 minus 1 times 100 over. Anyway. Yeah, just watch the math. All right. So we're going to subtract 1. Just do it. All right. Don't save that. All right, here we go. So minus float 1, and you can play with this. Maybe you can get float grid size. Okay, so that's going to be our y. Yes, and when I say y, I mean z, going forward and backward. Let's make sure. What do you want? Oh, float equals float I. Boom. This is an I. Float Y. For Z. Let's do it that way so it makes more sense. Okay. Yes. 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 Okay. Now I'm going to do the same thing, except put this as Vx, and this will be for x. Yes. Dude. Perfect. X, blah, blah, blah. Looks good over here. Everything's the same. Okay, so now we have our vertex points for Vx, Vy. Now we know that our y, Vy float will equal 0.0 because we're just going to make it flat. The y is not, we're not going to have hills or anything like that. We'll get into that later, and there's some cool stuff you ought to know about making dynamic like valleys and stuff, using stuff like Perlin noise, and heck, this way is even kind of cheap. We can use, we can get rid of all of this vertex creation on the CPU and do all GPU using tessellation, but we're not going to get into that yet. This is basic. Let's stay basic. Basic for just a second. All right. So now, our floats, our types, we have position. Now we need color. And I'm just going to say let color of every single one, which is going to be a float 4 equal float 4, and then I'm just going to say 1. Doesn't matter. Okay. So we have our color. So let position float 3 equal float 3, which is Vx, Vy, Vz. Okay, I should probably put these in order. X, Y, Z. Yeah, I'm pretty sure these are in the right order. I've been wrong before though. All right, if they're not, we'll fix it. All right, so now we have our position, we have our color. We just need one more, and that's normals. Now, if you look at the flat plane, whatever, it's flat, which means that all of our normals can just be facing that way. So, praise the sun, right? So let normals equal, just say float 3 position color normals float 3 equal float 3 1 0 1 0 straight up into the sky. Now this is where the tricky part comes in, kind of. Just got to use a modulo. We got to use a F mod, by the way. You can't just use a modulo, which is the % sign, because floats don't do that in Swift. So you got to use F mod, float mod. Learn that. All right. So for the texture, we're just going to say, I'm actually going to do it right here. So let texture X for the X value of will equal float equals F mod float of J mod 2. See? So we're going to go every 2, we're going to turn it back into a 0. Every other one, we're going to turn it back into 0. Okay? And then let ty float equal F mod of, this will be float, this isn't J, why do I keep doing that? Because I'm used to writing loops that say J. So X will be X, and then Z would be float. I need to play with these. I didn't do it like this. Okay, so now we have our texture, and we can say let texture float 2 equal float 2 tx tz. So like texture X, texture Z, position float 3. What are you complaining about? On VZ. Who doesn't know what VZ is? VZ. Expected type. Texture. Float 2. Be cool? Build it. Alright. So now that we've built that, and that looks freaking fantastic, we have our texture coordinates. Or we need to append. So vertices dot append. And then we'll just say a texture terrain. No. Append vertex. I knew I'd get it. And we'll do that. Give me some IntelliSense. And then we'll just pass in position color. I call this texture coordinates. Normal is going to be normals. Okay, cool. And then we're going to move this up. Move you down one. Cool. All right, so now it should be happy. Oh, we need one parenthesis. And so now we've appended all of our vertices. We built a freaking, yes, looks good. Vertices look great. Now, same thing, like I said before, we need to go through our indices. And that's just going to basically go through it. And let's pull it up. Oh, man. From here on out, I'm going to leave it open. All right, so let's go to File, Open. So basically, with the, we're going to just mathematically, go ahead and do the math yourself, son. Just kidding, but seriously, I'm gonna just type it. Actually, I might even copy paste it. Oh, Would you like that? I'll do that. I know you'd like that. I don't need to explain this. This is basically going through, this is a lot of trial and error trying to figure this out. But basically, and looking online and finding other people's code and trying to make that work with mine. So basically, we're going to draw that. So we need, remember, it's made up of, a triangle is made up of 3. So we're going to go this. So this. For every single one, we need to draw the indices. Okay? Cool. And so I'm just going to go here and copy this and just, oh, there it is. Oh, get rid of that space. So basically we're going to get the top left corner, the top right, the bottom left, and the bottom right. And then we're just going to append them as a triangle. So this is triangle 1, and then this is triangle 2. Simple. All right, that was easy. That saved me like 10 minutes. All right, I'm going to press the Control B. Take a sip. Sorry, I'm not the best at explaining things. Okay. So where we're at, 26. Probably get it done in 30 minutes. All right. You built. Succeeded. Okay. So that worked just fine, and I think, people, we are done. Let's go ahead and go back to our scene and create a new scene. Since we're using a scene graph, we could do this very easily. Let's start doing that. Let's start playing with this stuff. So terrain scene. Right, so it's going to be basically the basic scene. I'm going to take all this. We don't need this. Let's get rid of a lot of this stuff. Don't. Still want to move all this stuff. Don't need this stuff. Okay. Sure. Put the speed at 0.1. This will be terrain scene. It's going to be a scene. It's armadillo, add child, movable object, etc. Let's go ahead and go back to our renderer and change it from basic scene to terrain scene. That's how easy it is, people. Let's run it. I should just be adding an armadillo right now. Somewhere. Yep, there he is. Alright, let's check this stuff. Okay. That's not working. Don't worry. It's because it's a primitive. It's not a model. We don't actually have primitive... we have a terrain. Yeah, I think if we were to add a texture... So let's try stone on him. Should have kept up with this. Stone.png. Let's run it. See if it gives them a stone texture. And nope, doesn't do anything. Doesn't do jack. Alright. Oh, there is a little bit of ambient intense. Oh man, that looks awesome. Okay, that's not that cool. Anyway, we're not worried about that right now. We're worried about the terrain. So let's go ahead and say movable object equals a terrain. It's not a model, so we're not going to say model name. We're just going to say image name, and we are going to go ahead and find a grass. I found this beautiful grass. I'm going to drag it in here, finish, and I'll show you what it looks like. Oh yeah, that's our grass. That's simple. Just simple grass. 128 by 128. That's all I needed. It's a JPEG. You can make whatever you want. So now I'm going to go back to my terrain scene, and I'm going to say nothing, actually. I'm not going to pass anything. What's your deal? Terrain. Movable object equals a terrain. Come on. Alright. Alright, so now since it's 100 by 100, let's go ahead and press play and see what happens. I don't know what's going to happen. This could work, could not. Terrain. What are you doing? What's your deal? Do you know what that is? Did I spell it right? How many R's are right there? Spell terrain with 3 R's? Is that how you spell terrain? Is there any word that's 3 R's? Is anyone listening to me? Okay. All right. What's your deal? Looks good. Still going. Signing it. Succeeded it. Boom. All right. So let's give it a little zoom out. Okay. So you're gonna want to play with this a little bit. So it looks like it's there. Okay. All right. We probably want to rotate our camera a little bit, but let's go back out. Okay. So I'm just gonna go out. Looks like a little bit. Okay, 100 is pretty big. Okay, there we go. So one thing you can do is you can say, so since we know it's 100 by 100 and it's using those projection matrix stuff, so we can say camera.position dot, let's say in the middle of it, x equals, we'll go negative and whatever over 100 because it's 100 wide, right? So we'll say 2 over 100, that'll give us 50, right? So camera.position dot y, no, z equals, let's go back like negative 20, and we'll say camera dot position dot y equals negative 20, and then camera dot rotation dot x equals, we'll do 2, we'll do 3. I don't know what this is gonna do. Let me see. Oh, and also, don't forget, this is actually on that like 100 right now, so we gotta move that back. Let me see. Move it all the way back, negative back. So z, looks like z, we can do the same thing. That's gonna put us right in the middle of our, so we'll see the middle, and yes. Good. I don't know what this is going to do. All right, let's see. Yeah, I'm just looking at the values before. So we have 10 by 100, so that's going to give us over here. Okay. All right, so let's see. What the fuck? That doesn't look right. X, what are you doing? X, Y, X. Is negative 50. Oh, that doesn't give you 50, that gives you 0.2. That gives you 50. Math is really hard. I was like, what is my 100? I don't get it. Fucking silly goose. All right, so I'm gonna click this wireframe, and that's going to show you that we have a spectacular image with just beautiful vertices drawing, and they're drawing in the other direction. That has to do with the double for loop. I guess I'm drawing them in this direction. Hopefully that works, because we are about to add. See, okay, so now it's stretched over this long position, and you see it takes kind of a long time for me to traverse over. Look at that. So it's at 1. I mean, I'm moving. I'll move it up at the same time. See that? And what you want to do is, as opposed to doing camera dot rotation, you do self dot rotation. So you rotate the entire scene, not just the camera. Camera's supposed to be looking around. We're going to do self dot rotation. And since we're going to be, I think it needs to be negative, since we were looking our camera down, but since we're doing our scene, I think we're moving our scene in the wrong direction. Let's find out. I don't even know what this looks like. This looks somewhat correct. Yeah, no, that's right. All right, cool. So I rotated it down, and now if I press forward, it looks like we're actually kind of walking over this scene. See that? And it's big. So if I wanted to make it a little smaller, let's make it like a, I don't know, 20. A 20 by 20. This is just experimentation, just to show you guys what's up, and then I'll have to go in here and make it 20. We need to make this an initializer. Anyway, it's okay. Or we could have just upped our speed, I guess. But if you look at this, now, I'm going to click wireframe. I'm going to go backwards. I'm actually going to go. The shiznit is going on here? Okay, we're going to undo that grid size. Oh, because var z is going to be this y is way too high. Let's do -4. I should do it. It's 20 high. That's very high considering it's only. All right, there it is. See, now we're gonna travel across it a lot faster, but it's smaller. You see, like that's not realistic. If we were to put this wireframe on, that's not realistic. Like we get, here comes the world, and there went the world. This is not a Skyrim map. This is a very small map. As opposed to doing that, let's do something even cooler and push this thing to the limit. Push it to the limit. Let's go to 1,000, and we'll do 100 by 100. Actually, you know what? Let's do it. Let's do a little crazy. We'll do 120. Let's do 120, and then we'll make it 800. And we'll got to take this guy. Go back to terrain scene. I really need to make this better. 800 right there. 800 right there. Let's go back. Hope you guys are enjoying this. This is actually kind of cool. This is more, like I said, this is more graphics engine stuff, not necessarily graphics stuff. But let's put a wireframe on it and let's just start walking, son. Oh, look at that. That's really, really freaking cool. And then we can kind of go up and we're soaring. See? All right, so now let's go ahead and just add our grass texture in there, and hopefully it just works. And there's nothing else. So I took my grass.jpg, it looks like it. Press play, and we should now have grass, and we should now be walking over. Watch this. Oh, that didn't work. Oh. Okay, let me see what's going on here. Is that lighting? No? Oh, okay. That's funny. Our ambient intensity works, but our other stuff doesn't work, so I'll have to figure that out. Doesn't matter right now, because, look, people! Look at that! Oh, we are like on a world! So, we can make it even smaller. Let's do, let's go to our terrain. And, actually, I want to show you. So, if it was 100, and we were only using 2 vertices, which meant it was a 2x2, so the grid size was huge, but oh, no, I'm going to stop it. Grid size is huge, but the terrain is, it's stretched over the entire thing. Let's just for demonstrational purposes. And this is, you could probably stop if you really wanted to and go to the next one. But I can't promise there's not going to be any code. So now this is 100. Look at this. Watch this. Oh, we got to up it. Oh, look at how gross that looks. See? So we stretch it over the entire thing. Comes out pixelated. Let's do it 1,000 divided by 2. We're going to make it 1,000, and we're going to make it like, let's see if what kind of numbers we can handle here. Because we are using uints. Remember, we're only using uint 16. We can use uint 32, but I mean, we can only do so much. So let's go. Sorry, I'm thinking. Go to terrain. We're going to go to 1,000, and then we're not going to do 2. We're going to do, I don't know, 700. Remember, we're using uint 16. That only goes so high on indice values. So, is it good? Did it break? Is it going to say too much? Too many? Yeah, it just said too many. Saying like, dude, too much. I can't breathe. And so we're going to put that to 500. Yours might work. I think, so we're going to do 500, just going to be split right down the middle. Still broken. Yeah, see, this is giving this bad and this exception down here, and it's not showing me exactly the error. I should probably print out that error, but I think it has to do with this bottom left value being that number plus 1. So 65535 unsigned int. Let me see what the freaking total value is. So 16 bit. So uint 16 bit value. I guess I could do the math myself, but I don't want to. Highest bit value. That's what I meant. UN16 goes to 65,535, and it looks like we are at way too big. All right, so there's something we can do, and we're going to, because we want this thing to be as high def as possible. We're going to turn this to 32. Good thing you didn't turn this off, huh? Okay, this is really annoying. Sorry, people. Just go through all these, change them to 32. Fast forward if you want to when I start saying other shit. Looks good to me. 16, 16. It's going to say, no, you can't do that. You can't do that, dude. You can't do that. Yes, I can, and I will. And I'll go back to my texturable. Nope. Primitive. And we're going to go here down to UN16. It's going to be UN32. This right here is going to be instead of UN16. It's going to be UN32. And this is going to be 32. And are you happy? Let's build. See what happens. When we do tessellation, this won't even matter. Tessellation is awesome. If you don't know anything about tessellation, it's basically the CPU doesn't do any work. You create only a few vertices with a couple control points, and then the graphics processor does everything else for you. It'll create as many vertices as you want, and you can mess with them as much as you want also. So now, look, so now we're doing UN32. We can do plenty, and I'm going to go ahead and up this ambientness, and we're going to do that. And you see now, look at how clear that grass looks. Oh my god. Oh, we went through the ground. Look at that. Cool, huh? All right. So now that we're traveling through the world, if you want to try to add stuff, go ahead. I don't give a shit. Let's make that sky a little bit nicer, right? Like, oh, like a little bit of a, we're going off into this beautiful, beautiful sunset right there. What is it? Oh, yeah. It's kind of turned a little red. Yeah, it's a red sunset. It's beautiful. Gorgeous. All right, people. Yeah. So that's it. I'm sorry. I'm just thinking. That's how you render terrains. Let's. Oh no, not done. No. I fucking tricked you. Let's make this Z value craziness. So we have this Z value, Y value at least, not Z, going up and well, let's make it go up and down. And so there's a couple ways you can do this. You can use what's called Perlin noise to make it so it's kind of, you know, slowly, but like kind of, you know, makes it hilly. But we're not going to do that. We're just going to use random numbers. Screw it. And you do that using this thing says arc4 random uniform, and then you do this upper bound, and we'll just do 10 for now. Since we're going to 1,000, we could probably do like 50. And this is gonna blow your mind. Once we have, once I do Perlin noise and make it so we can do mountainous ranges, you'll, you know, this will be a lot easier to understand. Let's go up through the top. Looks like we're not through the top. Oh boy. All right, so that is not, so there you go. You can't really see them that well. Once we get lighting in here, actually lighting might make this kind of cool, but you see we have terrain rendering at random from 0 to 50. And what you can do is you can use a Perlin noise generator, or you can use this, doesn't matter, and create terrains that have height. So yeah, that is it for sure. I'm actually gonna get rid of that, put it back to 0 for now before I quit this. And what's my tagline again? Something to do with dying. It's something pretty gruesome. So I'm just gonna say, if I don't see you, good afternoon, good evening, and good night.